let me ask Karim Megherbi to join me on stage. I've got a microphone right here for you. Thank you so much for coming. Hello, how are you? You're the founder and executive director of renewables investment company Orisun, and you will tell us how climate change is making the case for decarbonation.
Yes. Good morning, everyone. So, I'm Karim Megherbi. I'm the founder of Orisun Invest, which is an origination platform. We put together developers and investors in renewable energy, mostly solar and wind, above 20 megawatt, and we focus on emerging markets. So today I'm going to speak about the case for decarbonation. And I start with climate change. So, since the creation of IPCC, the reports have been confirming again and again what we knew from 1970 around, which is that CO2 emissions coming from human activities are triggering global warming, which has different consequences on our planet. And among them, you have for example, here, and among them you have sea rising, you have, destruction of biodiversity and so on. And we put together probability now to these impacts and to the fact and to the correlation between CO2 emissions and global warming. And now we've been able to distinguish, to calculate what we call a carbon budget. A carbon budget is the number of, the quantity of emissions which are somehow left to have consequences on the temperature. So you have 1.5 degree, 2 degrees, 3 degree, and the more you have the highest the temperature, the more you can emit. Meaning that if we want to keep the global warming below 1.5 or 2 degrees, we know that we have to, and you can see on the right side, we know that our emissions have to decrease and reach what we call a net zero, which means that we have to almost non-emit CO2 emissions by 2050 or 2070. So we know where the CO2 are coming. You can see on the left side, and energy, our energy system, is 80% responsible for these emissions. And you can see in the energy, whatever is the use, aviation, marine, electricity, and so on, these emissions have to disappear in 30 years or 40, 50 years, depending on the probability and the bet that you are making on how precise our models are. And now, with the precision that we know on the climate change, actually the energy system, which allow us not to emit CO2. Also, we have a lot of research in the past 20 years. And now all the studies, regardless they are international, regional, national, we come almost to the same conclusion. Here I gave you just one example, which is the International Energy Agency energy mix. And you can see, I would say, I will have 4 principles. Look at the 2010. So first of all, energy, you need to divide it into fuel and electricity. Today, our world is 20% electricity and 80% fuel, okay? So at the top, you can see the fuel, and at the bottom, the electricity. So what are the changes that are going to happen, that have to happen, in case we want to stop emitting CO2? As you can see, fuel will decrease a lot, and it will be slowly replaced by electricity. That's one of the key elements that has to happen, which is electrification. But as you can see, it's not exactly equal. So first of all, it's on an international basis. So you have 2 trends. One is emerging markets, which are continuing to grow and which are absorbing more and more energy demand, and our OECD countries, where we need to decrease our energy demand by almost 40% as per these models. But as I mentioned, there is a very strong agreement based on all different models. So you have electrification, And you will slowly replace also all the different fuels by synthetic fuel and biomass under different forms. Biogas, biomass, etc. On electricity, the same here also. Obviously, it depends, wind, solar, offshore, onshore, etc., or CSP or geothermal. It depends on the resources of the country. So all these scenarios have to be national to make sense. But still, you can see that if you look at the different opportunities and potential of different technologies, there is no surprise, actually, that you can see in the IEA 70% of electricity coming from renewable energy. And the mix between solar, wind, offshore, etc., it depends, as I mentioned, about the potential. Do we have access to the sea? Do we have strong wind, strong solar? For example, if you take the GCC, solar is king in GCC, and there is no much variability. So you can have a strong penetration of solar. Obviously, solar does not produce on night, during the night. So you have to have this mix, adapted. And if I take Europe, for example, again, no surprise here. You have different scenarios. Either we want to accelerate, because as you know, we need to halve of our emissions by 2030. So we need to accelerate a lot all the elements that I mentioned: electrification, lowering our energy demand, going through biomass, and so on. So here, this is Europe. And again, what we can see is the strong role of wind, offshore and onshore. Why? Because we have very strong potential. We have very good wind resources in Europe. And plus, you have solar, depending on if you want to accelerate or not by 2030, and we should actually, then there's a push where we invest more in solar. And on the left side, and I'll come back in the conclusion of that, as you can see, there are different scenarios. One is we're very optimistic about the technologies. Everything is going fine. We're going to invest the right amounts in solar, wind, and so on. There is no disruption in terms of logistic. Everything is perfect. And so there's kind of technology scenario where we invest, and our demand, we don't need to make so much effort on an energy demand. So that's a very optimistic and probably very risky scenario. And that's the research. This is what they are showing actually more and more. And now I believe that the energy mix, the research in the research centers and industrials, and even actually our utilities, they're going to emphasize on the different strategies to lower our energy demand. I'll come back to that. And here you can see actually the increase of, regardless, different scenarios, on the different scenarios, but you can see the trend is very clear. We need to accelerate in the, in investment in offshore. So the first one is offshore, the first one is onshore, offshore, and solar. As you can see, there is no scenario where you don't have a very strong increase in capacities, even in the scenarios where, as you can see, system change on the right side, where we actually constrain a lot our energy demand. So what does it mean in terms of energy mix? So again, these utilities now, it's above, it's beyond actually academic research. Now utilities in the world, Australia, US, etc., they're now working on how to manage this energy mix where you have intermittency, variable energy, renewable energy. So we have also a very good idea actually how to manage that. And here this is a simulation from RTE in France. And as you can see, there is a yellow band which is nuclear, so it's from France. And as you can see, what we know now, it's over the time where you have base load and some adjustment with peak generation and so on. Our energy mix and the stabilization of the grid will depend on flexibility, on the connection between all our generation asset demand, distribution, transportation, generation. And this is complete change actually of paradigm. And that's what you can see on the left side, where actually now the communication will be directional between the consumers, between the producers, etc. And all the flexibility tools will happen both at the consumers and also at the generation. And communication between all the elements is going to be key. On the right side, on the bottom, you can see also the role of interconnection. So You just need to see the lines, actually, which are, you don't need, So we see here the big investment that will happen in transmission lines, because we need actually to be able to not only export and import electricity, but also we need to share flexibility among countries. We need to share hydro dams, which are going to be big batteries, no longer base load. Hydro will become actually batteries. That's what's going to happen. So it's a complete change of how our energy system will work, but the path is clear, and we do have studies and investments, and it's going in this direction. And you can see hydrogen also, which is going to play a role, but post 2030, 35. So here, where we're going, that's the investment trends actually that has to be expected. Here, well, there are plenty of scenarios. So some of them, they love hydrogen. Some of them, they love solar. Some of them, they love batteries, etc. So, let's see, okay? But the directions are very clear. We know that we're going to invest a lot in grids. We know that we're going to invest a lot in renewable energy. And we know that actually we need to almost double this investment by 2030. Today in the world, we have maybe 340 gigawatts capacity installed per year. And we need to reach 1 terawatt per year by 2030. And the trend has to continue for the next 30 years. So it's, we have a very good view, regardless of if we constrain our demand, regardless of how we're going to manage the grid, etc. We know almost, the directions are very clear. So where are we going now? Is it working or not? And I'm almost done with my presentation. Well, in OECD countries, remember that electrification has not yet started. The renewable energy, I would say the kickstart somehow was 2005, I would say, because thanks to the feed-in tariff in Europe. So that's when actually the industry, slowly went to China, and prices have been decreasing by 90% and 60% for solar and wind during the 2010 and 2020. So that's the kickstart somehow, 2005. And electrification is coming only because our LCOE became very cheap. That's why we have electrification. So electrification is very new, meaning that today, the impact on our energy and our CO2 is only on electricity. And now that we're going to start electrification, we're going to jump from progressively from 20 to 50% of electricity. And that's where we're going to eat, actually, the fuel that I mentioned, this 80% CO2 emissions coming from the fuel that we burn every second, actually. So that's when we're going to, eat that one. So what's happening on electricity in electricity? Yes, it's working. We do have fossil fuel, decreasing. Coal for Europe is very clear. The trend is absolutely clear. We had, with the Ukrainian war, we know that, we had to, restart some of the coal, etc. But it's very temporary. The trend is absolutely clear. Renewable are growing, fossil fuel are decreasing, and everywhere. In the US also it's the same. As you can see, they slowly impacting. And now, thanks to the very strong policies that passed in Europe, REPower EU, Inflation Reduction Act, and in China also all these policies, climate policies, or decarbonation. Now we see this trend accelerating. However, what's happening in emerging markets? Remember that emerging markets now today, 2/3 of our emissions in the world, they're coming from emerging markets. So what's happening there? Well, in emerging markets, as you can see the share in India, so let's take the two big countries where everything today is happening. After that, we'll see other emerging markets coming, but in terms of population and growth of economy, these are the two big economies. India, it's not, we're just fueling their growth. That's it. So the share that you see on the top of coal in electricity is not decreasing. In China, yes, because in China, there is a very strong push in constraining the demand, and at the same time, although energy efficiency also India is investing a lot. In China, they have very strong policies where they actually half of the capacity installed in the world of solar PV they are in China. And plus they do nuclear, etc. So they have very strong program. So they are able today, despite having an economic growth which is double the size, double the speed, double the amount of what we knew OECD countries in 2017 and 2000. So when we had a strong growth, it's doubled the speed in China. Despite that, we're able actually to decrease, and hopefully when things will stabilize and they will reach hopefully a size of infrastructure and growth which where they can actually now have a demand which is, as OECD countries, flat. Now they're going to decrease drastically. In China, it's planned for 2030. So here, my conclusion is, what does it mean, decarbonation? At the end of the day, it's not only investing in renewable energy. Well, it is also, obviously, as I mentioned, electrification and low carbon electricity. So meaning that, for example, in Europe, onshore and offshore wind are playing a very strong role. And offshore, it's very clear, it's below 50 euro per megawatt hour. You have a capacity factor today, 40, 50, maybe more than 50% of the time. So these are very, very unavailable assets to develop as much as we can. Finish? Okay. So there is this investment in technology. But I want also to mention that if we want to deploy technology...
Yeah,
If we want to deploy technology, it's also about a social agreement altogether with citizens. Because, all these assets, and we were going to reorganize our society. So that is a very strong, a political willingness, actually, to have citizens behind this development of decarbonation. Yeah.
Thank you.
Thank you.